All right, so we have a file to download today, starwood.xlsm. Go ahead and get that downloaded, and our topic for today is arrays. We'll talk about this here in just a moment. Get that file downloaded and opened. But first, we're going to spend 2 days on this idea of arrays. And it turns out, like in the world of programming, almost every programming language I know of, in fact, with the exception of Lisp, you have the construct of an array. And who knows? Maybe maybe Lisp has it now too. I don't know. But an array, we speak of it as though we've said enough when we say an array, but we haven't. Someone just tell me, what does an array mean in English? The English language definition of the word array. It's a real word. We were singing Hope of Israel in church, not last Sunday, but Sunday before or something, and there's a part of it that says, and the battle's in array. I said, wow, the arrays are right there in the hymn book. It's not like a programming hymn book where you're singing code or something. It's a regular hymn book. And so this is a word that we use. Has someone looked it up yet? Looked for Google, the definition? Yeah, you got it? What does it say? Not just a list. I want a richer definition. You know, go to Google. Google's always good. This is a definition of array. A series or arrangement, that's all it says? An orderly, read the whole thing to me. I don't like that definition. An orderly, often imposing arrangement. Yeah, someone give me a different one. It's not too bad. We can work with that, but there got to be a better one out there. Anyone else got something different? Okay, there we go. Okay, it's an impressive. Say it again. An impressive display or range. So we're already talking about ranges. Hey, that's good. It's not that kind of range. And that's the important part of a particular type of thing. So would it make sense if I just kind of stood over here in the corner and gazed upon all of you simultaneously and said, "My, what an impressive array I see." Does that make sense? Sort of, but what am I missing? What should I say? My, what an impressive array. Yeah, of students. I was thinking of the chairs, personally, but of students. Yeah, there's an array of chairs here. An array of desks, there's an array of students, there's an array of smiles. An array has to be an array of something for it to really make sense. And somehow, in the world of programming, we think that when we've said array, we've said enough. We haven't. An array is an array of something. And it's true in VBA too. It's an array of something. No one ever says what it's an array of. But you're in luck. I'm going to teach you what it's an array of today. You ready? When we say array in VBA, we mean an array of variables. It's an array of variables. Oh, now, I've been working with arrays since I was like 12 years old, and they seem natural and easy to me. But let me tell you a story, more for my benefit than yours, to remind me that when you're first starting with arrays, it's not necessarily easy. Actually, I know some of you have some programming experience already, so just by a show of hands, who already here can use arrays? Whew, I know why I can. Every time I get a paycheck, I look at it and say, boy, I sure could use arrays. There's not really that many good jokes, here in programming, so you got to take them when you can get them. So, when I was like 10 years old or so, I was visiting Uncle Jim. He lives on First Avenue. He's dead now. His wife's dead too. His daughter now lives on First Avenue in Salt Lake City. Big Victorian, wooden home. They had a couple of apartments. Were kind of separated. The top floors, were a couple of apartments. And while I was visiting during the summer, one of their renters fell asleep smoking and lit the house on fire. And so it's like 5 o'clock in the morning, and I'm sleeping in a bedroom in the basement. I'm at the bottom. It's a huge house. And my father comes into the bedroom, and he says, I'm not kidding, "Son, the house is on fire. The firemen have asked us to evacuate the building." That's what he said, and it was with about that much enthusiasm. And so I thought, my father was not a prankster or a jokester. There was no doubt in my mind that the house was on fire and I needed to get out. So, I got my shoes and put some clothes on and went out. By that time, the fire was out. And there's fire trucks there, and they're spraying water. Now, it turns out Uncle Jim, owner of the house, a brilliant programmer. My father was a general contractor. And so Uncle Jim says, hey, Gary, that's my name. Gary, how about I hire you to do the work to fix the house? And as part of the payment, I'll teach you to be a programmer. So my dad, for a couple of years, he's working in the house. At night, he's learning how to program. And after he finishes there, Uncle Jim was good enough. Uncle Jim hired him, and he had a company in Silicon Valley. And, he commuted from San Diego, which is where we lived, to Silicon Valley for a couple of years, every week. Fly up Monday morning, fly home Friday night. And so by the time I'm 12, we have like a serious business computer at home. My friends, they have like the VIC-20 or the Commodore 64. Google those. You've never heard of them before, but they're really wimpy computers. And we got a serious computer at home, so I'm learning how to program, doing great things. And I'm about 12, and my father pulls me aside and he says, son, it's time we had a talk. You really need to learn about arrays. You're in your programming development, you need to learn about arrays. I said, great, Dad. Whatever it is, I want to learn about it. Now, my dad was an okay programmer, and he was a really bad teacher. And on this moment, the combination of those two things, they just felt deadly to me. So he starts off by saying, arrays are like pigeonholes. Now, I'm like 12. I don't know what a pigeonhole is. I know what a pigeon is. I know what a hole is. And so I have some image of a bird and a hole. And okay, arrays are like pigeonholes. And for about 20 minutes, if you're ever teaching somebody with the use of a metaphor, make sure you're familiar with the metaphor. Pick something they know about. That's the whole point for a metaphor. You know about this thing. I'm going to use that. I had no idea what a pigeonhole was. Okay, so after about 20 minutes, I'm utterly baffled about what he's talking about. And so I said, okay, forget about the pigeons, forget about the pigeons, forget about the pigeons. Arrays are like post office boxes now. San Diego mail, like a lot of them are out here. You got a stick sticking in the ground with a mailbox on it. That's not what he's talking about. He's talking about when you go to the post office, there's an array of post office boxes. They really are. They're orderly, rows and columns, and they're all there. I've seen those, but when he says post office box, I'm thinking mailbox. And, there's at the end of our street, there's maybe a dozen of them, and they're all different shapes and sizes, and they're kind of, some are leaning over. And, another 20 minutes or so, I'm in tears. I'm thinking, I'm a moron. I can't understand this stuff at all. Dad's in tears. He's thinking, my son's a moron. He can't understand this at all. We gave up. All right, we're just going to go our separate ways here. He must have been so disappointed. Here I am 12, and I can't understand what an array is. Okay. So the point is, that when you first get exposed to this can be a little bit confusing. The good news is I am an excellent teacher, and so you're going to get this, today while we're right here. All right, so let's look at the context that we're going to use arrays. Even before we look at the context, let's just kind of let's dip our toe into the array code. Alt F11. So what metaphor am I going to use? I'm going to use no metaphor whatsoever because arrays are arrays of variables. And fortunately, you know what variables are. Let's take a look at it right here. So actually, an array is like a clown suit with lots of different pockets on it. I don't know. Insert a module. Let's make a sub-procedure here. I'm going to call this sub-procedure, I'm going to call it init, like short for initialize, init. All right, let me declare a variable here. I'm going to declare a variable called hotel as a string. So the idea here is I want to put the name of a hotel in here. So great, hotel equals, let me just pick up one of these, the Sheraton Downtown Los Angeles Hotel. And I'm going to print that, debug.print hotel. This so far should be review. So I'll run that, get rid of the 5, run that, and Control G. Immediate window is kind of small. Let me open it up. We should see in there Sheraton Los Angeles Downtown Hotel. If I can open my immediate window. There we go. Print twice because I ran it twice. All right, so there is declaring one variable. Now what I want to do is I want to create an array of variables. I want to create 10,000 variables. variables. Watch this. You ready? Don't blink. You'll miss it. 10,000. I am now, just by taking my declaration of my variable and putting parentheses right after the variable name and putting a number in there, I'm now making more than one variable. In this case, a lot more than one variable. But now, all of my variables in this array of variables have the same name. It's now the name of the array, and to get to the individual variable, I need to supply the index. And so I can't just say hotel equals. I got to say which one I mean. I mean hotel number 17. I just created 10,000 variables, and now I've just put a value into a particular one of those, number 17. And so now that should print out exactly the same thing, because I've got now just multiple variables. So now when I refer to the variable that I want in this array of variables, I have to use the number to tell it which one I'm after. Okay, it gets harder than this, but how are we feeling so far? How many of you are saying, this brought you to tears? I mean, sure, you were 12, but this brought you to tears? No, it was the pigeons that brought me to tears. Question? Yeah. Right, yeah, so the question is, what's the 17 business here? And the answer is, now that this is an array of variables, I got 10,000 of these here, and so I've got to tell it out of all those 10,000, which one am I talking about? I'm talking about the 17th. And if I want to print out the 17th, what happens if I print out the 18th? What do you think? Not an error. There's 10,000 of these. 18? Not even close. Yeah, it'll print out the default value for those variables. What's the default value for a string variable? Yeah, zero length string, empty string. So you're not going to see it do much. But let me see if I can put go above this, and maybe we can push it down. Alt, Enter, Control, Enter. Okay, I'm going to be right here when I run this, and I think that at least you'll see it bump down, but it's not putting anything new up there, because zero length strings are very difficult to see. You got to zoom in really, really far, really far. You'll see. Go ahead. Oh yeah, so I said, I was a little bit sloppy. I said I've created 10,000 variables, and that's true, but I have also created 10,001. You can't create 10,001 variables without creating 10,000. So you're always going to create 10,000. I wasn't, lying to you. But the very first one is 0. And so when I put 10,000 in there, I'm telling it what's the top index that I'm after. And so in this case, it actually creates one more variable than the number you put there, because they start counting at 0. There's a good reason for why they start counting at 0. Do you want to know what the good reason is? The reason is that, remember, when we create a variable, someone tell me what's a variable? A variable is a place in memory with a data type and a name. Yeah. So a variable is, there's some location in memory. Give that a name. It's not a name for all the locations, because if I'm doing the smallest variable we can do, byte, it's 8 bits. Each one of those bits has an address. But we go right to it's the name for the first bit, for the address of the first bit, and then the rest of it just follows. Well, it's the same thing for the array. This array is actually located contiguously in memory. All 10,000 of those strings, 10,001 of those strings, they start at a location in memory, and they're contiguous. And the place where they start, that address is named. What's the name of the address where they start? What's the name of the address in memory? Remember, when I have a variable in memory, I've got a location in memory, and it's named. That location, the starting place in memory, is named. Same thing here for the array. The array starts at some place, and then all the variables in that array just go up. The name of the array is the name of where that array starts. So here it's called hotel. We've named that address hotel. And now, the data type in this case, let's suppose the data type was integer. So we got 2 bytes, every 2 bytes. So the index tells us from the starting point how many of our data type sizes do we offset. So since the very first part of my array is starting at where the array starts. The very first 2 bytes of that array is the first variable. The offset is 0 because it's an offset from where the array starts is what that number is. Now, the good folks in Washington, when they're making this language, they thought, you know what? Isn't it easier to start counting at 1? I mean, like you've been counting it. When you started to learn how to count, like probably even before you got to kindergarten, did you start with 0? I like try to do that with my kids when I teach them how to count. Okay, we're just going to start counting at 0. That was a really bad idea. We changed. All right, forget it. We're going to start counting at 1. There's good reason you start counting at 1, when you're young, because 0 is kind of a tough idea to understand. But the folks in Microsoft, they said, you know what? Why don't we start counting at 1? And so watch this. I mean, why don't we give them the option to start counting at 1? Option base 1. If I put option base 1 up here at the top, it says, all right, any arrays that I declare in here, let's start them off at 1. So now, how many variables have I created? Yeah, now I've created 10,000 even. And what do you think is going to happen if I try to run this code the way it is now? One-time error, which number? Runtime error 9. What's the message? Subscript out of range. Let's see if it does it. I dearly hope that's what happens. Look at that. Runtime error 9, subscript out of range. Yeah, because the 0 is out of range. Now the range is 1 to 10,000. Okay, so that's the idea of an array. Now the whole purpose of this is that, listen, I could put in here, and the whole reason that we do this is because now the variable name, I don't have to identify that variable name or that individual variable by its name. I can use its name plus some number, and any numeric expression will do here. 3 plus 4. And then here I'm going to do 9 minus 2. So which element am I referring to with this one? Which element am I referring to with this one? Yeah, I can have some kind of logic involved that figures out, of all these variables, which one am I talking about? Use a variable or some other kind of expression to get there, and this should now print that because even though the indices are different for both of those, they evaluate both to 7. And so we're able to get at it. It becomes really powerful as soon as we start using loops to be able to do this, and we're going to do that here today. But let's get introduced to our problem for the day. So just suppose that you've taken a job, you just graduated. How many of you are graduating in April? Okay, you just taken your job, and you got hired by the Western Regional Office of the Starwood Corporation. You're gonna be some analyst. I don't know what you're gonna be doing, but anyway, your boss says, "All right, listen, we just hired you. No one in the whole company knows that you work for us yet. So here's what I want you to do. I've got these 36 different properties. Some of these hotels are top-notch. They're really doing everything right. Some of these are, we're not sure we're going to keep them open very much longer. But what I want you to do is I want you to go to all of these 36 hotels and visit them and use their services. Eat at all the restaurants. Go swim in the pools. Try, go to the sauna. Get a massage. Visit the masseuse while you're there. And, just find out. Keep notes. Are they doing well? Are they not doing not so well? You're thinking, hey, that's pretty good. How many of them are there? Well, there's 36. Oh, hey, I'm married. I got a couple of kids. Great. We're going to rent you a van. It'll be conversion van. It'll have like airplane lights on the inside. And you take the family and you just go. And so you're available for this job. And you say, okay, well, I'm just graduating. I got more debt than anything else. How am I going to afford it? No problem. We got the corporate card for you. You just you don't pay it or anything. Just go. So you're thinking, hey, okay, this is not so bad. The truth is, this job is going to get old after about 2 weeks. But you make the best of it. So you're thinking, okay, great. So you figure out your starting point pretty quickly. Where do we start? Salt Lake City. So here's the closest one to where we are right now. So you're going to start off in Salt Lake City. And now the question is, which order should I go to all these hotels in? And your new boss says, I don't care what order you go, just go to them all before you show up for work in 3 months. Go to them all. All right. Now you got to figure out what order do you want to drive to these places in. Now, don't actually tell what I don't want to hear next is, okay, Salt Lake, then Las Vegas, then Phoenix. I don't want to hear that. Give me the description of the route. What's the characteristic of the route that you would like to take? Tell me, of the route that you choose, what's the best one? It is the route that is the shortest total distance, right? Because every minute in the van with the kids is one less minute with the masseuse, right? So, okay. So that's our chore for today. We want to be able to, and fortunately, the data that has come to us as if from heaven is, it's road distances between all of the properties. So how far is it from Los Angeles to Salt Lake City? Here's from Los Angeles to Salt Lake. It's 691 miles. How far from Salt Lake to Las Vegas? 425 miles. That sounds about right. I mean, yeah, some of you are probably familiar with those distances. That sounds about right. By the way, how come there's not a number right here? Yeah, this is from Salt Lake to Los Angeles. This is from Los Angeles to Salt Lake. It's the same number. Sometimes you'll see these charts like on the bottoms of maps, like the distances between major cities, like you're visiting Europe or something, and it'll show above the diagonal, it'll show kilometers, below the diagonal, it'll show miles or something like that. So, but it's the same distance. Okay, so someone tell me, how are we going to figure out the route? What are we going to do? This is our task. Ultimately, it's going to involve arrays. We're going to implement in VBA an algorithm to calculate our route for us. But before we think about this algorithm in VBA, let's think about it in English. So, or Spanish, I don't care how you think about it. But when you say it to me in English. Describe how you come up with a route. How would you come up with the route? Go ahead. Okay, take two places. Okay, so what you're saying is, start somewhere. We start in Salt Lake, and now find of all the other 35 properties, which one's the closest to Salt Lake? Turns out it's Las Vegas. So then you're saying, go to Las Vegas, and then find out who's the closest to Las Vegas. Turns out Salt Lake is the closest to Las Vegas. So you want who's the closest to Las Vegas? More generally, that we haven't been to yet. Yeah, that's the algorithm. Yeah, that's a pretty good algorithm. So you're going to say, great, we're starting in Salt Lake. Who's closest? Las Vegas. All right. From there, who's closest that we haven't been to? Go there. I think it's like Palm Beach or something. I don't know. Maybe it's Los Angeles. Then, okay, who's the next one? And you can say it that easily. Go to the next nearest city that we have, next nearest hotel that we haven't yet been to. Wow, I can sentence. Just keep doing that till I'm out of hotels. Yeah, that's pretty good. Virtually guaranteed not to give us the shortest route. But it'll give us a route, so it's got that. That's good. We made some progress. We got a route. Other thoughts? Yep. So what you're saying is so what you're suggesting is we want to just figure out what all the routes are and pick the shortest one. Yeah. It turns out, and some of you probably know the name of this problem. I mean, it's disguised because it's hotels. But what's the general name for this problem? Go ahead. It's called the traveling salesman problem. It's a problem that we as humanity have been studying for about 300 years. And today, mathematicians spend their careers working on this problem. And you have just given us the only known solution guaranteed to give us the shortest route. And that is calculate all possible routes, pick the shortest one. Okay, how many hotels do we have? Let me make a new tab here. Zoom in just a bit. I'm almost surprised when I ask this next question, and almost someone knows right off the top of their head. 36 hotels, how many possible routes are there? Not the number, but the actual, 36 factorial. The first time I tried to figure that out, it took me hours to figure out, it's 36 factorial. And someone just knows off the top of their head. Great, 36 factorial. So, fortunately, in Excel, I've got factorial, F-A-C-T, 36. That's how many routes there are. Turns out I'm not very good with scientific notation, so let's make this to like decimal. There we go. That's how many routes, 0.00, in case you're wondering. So, but no problem. I got a computer, and it might take a little while to solve the problem. So one time, I actually thought I was going to solve the problem this way. And so I set it to run, and it wasn't finishing anytime soon, so I thought, I wonder how long it's going to take. And so I timed my computer, how many it could do in a second. And I was kind of surprised. I mean, this was still like early 2000s, but it was calculating 5,000 in a second. So my computer's probably fast. Let's double the speed right now. So we're going to say this. Now let's go ahead and say how many seconds it would take to solve this. So I'm going to divide that by 10,000. That's how many seconds it's going to take. Still I can't even think of that number. So let's take that and divide it by 60, which should give us minutes. Divide this by 60 hours. Divide this by 24 days. Uh-oh. Divide this by 366. Give yourself the edge there. That's how many years it's going to take. Now, I don't think I'm solving that problem anytime soon. No, well, hold on a second. I just need to get more computers involved here. I read not long ago that the 1 billionth PC had been produced. So let's just take that as a surrogate for the processing capacity of humanity. So I'll take that, and I'm going to divide it by 1 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. I don't know how to say that number still. I need some number I can say. Okay, what is best scientific estimate for the age of the universe? Anyone know? I know we're in a business school, but someone probably knows it. Wait, we have a physicist. Is our physicist here? Our physicist. It's so awesome to have a physicist. Okay, so this divided by, we say 13 billion? Okay, we'll go to 14 because you're going to round up. 14 billion. 1, 2, 3, 4, 5, 6, 7, 8, 9. Ah, a number I can say. 84 trillion? Is that what that is? Let's see, that's thousands, millions. No, this is millions. That's how many millions. Yeah, it's 84 billion. It's only, I mean, heck, we could build a couple of walls for that. But that's how long it would take. 84 billion times as long as the universe has been in existence if I dedicated all of humanity's processing power to solve this problem. Folks, it turns out you could drive the worst route dramatically faster than you could calculate the best route. Really. And in fact, yeah. So we're not going to try to calculate the best route. Now, I mean, math has gotten better than this, right? So, and where this problem, where we solve this problem, we say, well, there's probably large portions of the search space that we can throw away. We're pretty sure that if you go from Salt Lake to Los Angeles to Seattle as your first 3 steps, that's not the best route. Because there's some other places down in Seattle. So we can say, let's throw away large portions of the problem and get the space down. But still, this is the problem that we still to this day cannot solve computationally. We can 100 and be 100% sure that we've nailed it. By the way, is this a problem that's interesting for anybody besides mathematicians or physicists? Or for traveling salesmen? Yeah, actually, when you say traveling, that's right, but it's not the salesman. Who is it that's really interested in this? Give me the name of a company. Google's not so interested as other people. Okay, so they're trying to answer these questions. Forget the people who are trying to answer the questions. Who's asking the questions? Amazon is, UPS, Federal Express. Anyone who says, I got to make a bunch of stops today. I got all this stuff I got to deliver. I got to make a bunch of stops. And so, but the problem actually is even way more complex than that, because think about, if you're driving a Federal Express truck, it's a lot different if you make a left turn than if you make a right turn, yeah? Turns, you got to wait for traffic. You're probably going to have to wait longer, and it's more likely that you're going to get in an accident if you make a left turn than if you make a right turn. And so, even saying we want to be able to find the shortest route, but we're going to weigh left turns differently than right turns, that's a complex problem to solve. We're not going to solve the problem today. I mean, look, we don't even have just barely like a half hour, and so we're not going to come close. But we are going to be able to calculate a route. We're going to have Excel calculate a route for us. And we're going to use, who said it? Who said next nearest city? Someone's, yeah. So, oh, someone up here. So that's the algorithm we're going to do. So next nearest city is a really easy algorithm to say. It's going to give us a route. It's going to be a pretty good route. Probably, the chance of it being the best route really slim, but it's going to be a route. And most importantly, it's going to give us a great opportunity to use arrays. Okay, so let's dig in. Back to our problem here of init. Now, we're going to end up having a couple of different sub-procedures that need to have access to these arrays. So, little sidestep here for a minute. Oh, I'm taking option base 1 off. And let me give the warning here, and that is, you will be tempted. At some point, while you're doing this, maybe the project that goes along with this content, or some point, you will hear a little whisper in your ear that says, it would be easier if you used option base 1. And you're going to look around, who said that? And that's the devil. That is an evil spirit trying to talk to you. Here's the reason. If you learn about arrays with one-based indexing, you're going to be okay anytime you have to make your own arrays. But anytime you have to look at someone else's code, it's going to be a real problem for you to make the mental shift to go to zero-based indexing because you never got familiar with it, and it's really, really common. Instead, we're going to take a little extra effort to do zero-based indexing because making the switch from zero-based to 1 is a breeze. But if you've started with 1 base and you got to go to 0, it's a nightmare. So if you want to leave the option base in there, make it option base 0, that's fine. It's exactly the same as not having any option base specified. Okay. So now we have to look at kind of something else. And this applies not just to arrays of variables, but to all variables. Where you declare the variable is important. So right now, the only place you've ever declared variables in this class has been inside of subprocedures. And if I declare a variable inside of a subprocedure, it is accessible to other code that is inside that subprocedure. Well, what if I have some code in a different subprocedure? I want to access the variable. No can do. Unless you say, no, this is not going to be a local variable. It's going to be a module level variable. So instead of declaring my hotel here, I'm going to declare it right up here after my options, but before any of my subprocedures. Okay. The legal place to declare a variable, or in this case, an array of variables. And now this variable will be available to any subprocedure in this module. If I have another module, subprocedure, different module, can't see it. But other subprocedures in this module can see it, so that's great. It's not global, it's module level. I can make something global, meaning any module can see it, by saying global instead of dim. Or by saying public instead of dim. If I say private, that's exactly like saying dim. So this notion of public versus private came along after. It used to be dim and global. They said, well, these are public or private variables, and so they gave a different name for it. I'm going to stick with dim. It's exactly like saying private here, just because that's the statement we're familiar with. And actually, there's a little bit of trivia. It used to be that in the early days of BASIC, you didn't declare variables, you just used them. And they would be declared automatically for you. But you had to declare the array. And so you had to tell BASIC the dimensions of the array. And that's where dim comes from. So dim is short for dimension, and it used to be you only used it when you were setting up how the dimensions of your array. That's where the word comes from. When they decided we wanted to declare individual variables, they said, oh, it's just exactly the same thing as doing an array, so let's just use the same word. I was reading a website somewhere where it said, this stands for define in memory. And I thought, it does not. I mean, okay, this is maybe not a bad thing to say, but that's not where I know. And that's not working. Okay, so now we've made this a module level variable. That would be just fine. We don't need 1,000. How many do we need? 36. So what number do I put here? 35, right. Because I start counting at 0, and I put the upper boundary that I'm after. Now, right now I've got 35 property. What happens if I add a property? Or what happens if I import a different sheet? Now I'm not doing the West Coast. I got to do something over here in South Central United States. I got same problem, but different hotels. And of course, it's not going to have the same number. So instead of hard coding this number, I want to make a dynamic array, one that I can change the size depending on the problem I'm working on. Here's how I make a dynamic array. Ooh, dynamic array. The problem is that when I declare variables, those variables, like this statement, gets processed. It doesn't really execute, but it gets processed before my code starts to run. If I have a local variable, it says, okay, I'm getting ready to compile this sub-procedure. Look at all these variables declared here. All right, I got to go make that memory, allocate that memory, and then start running the code. And so the memory gets allocated before I'm able to do any computations to be able to find out how big my problem is. And so here's what we do. I can't just put a variable up here. Instead, I put nothing. So it's just hotel, open parenthesis, close parenthesis. This is now a dynamic array. Now this means before I use that array, before I can say hotel 3 plus 4 equals something, I've got to give it a size. Dim is not executable, but it has a counterpart that is executable called redim. I'm going to redim hotel, and I'll just put the size that I want in here, 35. And now this should work just the same way that it did before. That seems so strange. Why not just dim it as 35? And because our next step is going to be to figure out the 35. So let's do this. I'm going to create a variable here called hotel count. Hotel count as an integer. Hotel count. Hotel count equals, now I want to come over here to my distance worksheet, and I just want to figure out, how do I find out how big my data are? I got to come down here to 37. When I have 37, how many hotels do I have? I mean, when I'm on row 37, how many hotels? Yeah, 36, because the top one's blank. And so let me just go ahead and start all the way down at the bottom, do an end XL up, so I bump into that, and I'll be able to figure out how many hotels I need. So I've named distance. I've actually given it a code name of distance. Whoops. So we don't have to say worksheets distance. I can just refer to it by its code name, which is also distance. Distance.cells. Which row do I want? Rows.count. How many rows are there? 1.04 million. So this is going to evaluate to that number, the very last row. And I'm talking about column number 1. From there, that refers to a cell. There's an end method. I can then give this, whoops, no quotes. I just say, which way do I want to move? End XL up. And that will take me up to the cell, actually the cell that has the data, and I want the row. So that's going to give me 37, but because I don't have anything in my first cell in that column, I really want, my hotel count is really whatever that number is minus 1. And so now I've calculated how many hotels I have, and so now I'm ready to create my 36 variables here by saying hotel count, hottie count, hotel count. How many elements, how many variables in my hotel array would this create? Not 36. Not 36 squared. You're really close at 36, very close. It would create 37 because my hotel count is 36. I got 36 hotels. This would give me dim 36. It would be 0 through 36, which is 37. See why the option base 0 is a little bit more difficult to start with? And so if I want only 36, what do I declare this as? Minus 1. So that'll get me to my 35. That will declare this as an upper boundary of 35, which gives me 36 elements in my array, 36 variables in this array of variables that I can now work with. Okay, so now I'm going to go ahead and run this, see that it works, and then I'll take your question. So delete that, run this. Good, still working just fine. Question? So could you say option-based 1 and have it only affect one single array? And the answer is no. It's an option. It's a compiler directive. So it says all of our arrays get set like this. But I usually don't show my students this because they don't ask such insightful questions. You can actually come in here and say, I want this to go from 1 to that number. So it's not an option base, but you can set a different starting point. Now your option base can either be 0 or 1. But you know what? This could be whatever. I could start this at 12, the hotel count. So you can actually make the indices kind of go wherever you want them to go. They'll be sequential. You can't make them skip every other one. They'll be sequential, but you can start the index wherever you want. We're not going to do that just because it kind of adds more complexity. The question is, does the option base only apply to this module? And I think the answer to that is yes. But the truth is, I don't ever use option base, so I'm not sure. But option explicit only applies to the module, so I think it must be a module level directive. All right, so now let's load up the array with, let's load up the array with the real names of the hotels. It's so exciting. Let me, before I do this as a loop, which is of course where we're headed here, let me just get like 3 of these done up to start with. So I'm going to say hotel 0 is my first one. And I'm just going to go read it right off that same distance sheet. So distance, A-N-C-E, dot cells. I'm going to say row number 2, I think, has my first hotel in it. Yeah, because number 1 is blank, number 2 is my first one, and column number 1, dot value. I'm going to do 3 of these just so I can kind of see the sequences that we're working with, and then I'll generalize it with a loop. So I'm going to look at hotel number 1, hotel number 2, where I'm putting the values in. I'm going to look at row 2, row 3, row 4. And here, let me just go ahead and to start, let me start off by printing hotel number 0. So that should still be our Sheraton Los Angeles downtown. But now, if I run this again, but print hotel number 1, I should get a different one up there. Yeah, so now I got my Salt Lake City. And whatever the next hotel is, I could get access to that one as well. So now I want to do this with a loop instead of, writing them all. So this is what the for loop was meant for. The for loop was invented for this very purpose. So I'm going to declare myself an integer variable, dim x as an integer, for x equals, and I could either go 2 to 37, or I could go 0 to 35. Or I could even go 1 to 36 and then adjust both of these indices, but let's pick one of these. I'm going to go 0 to 35. And now, let me just duplicate this line and push each other down. They're now slated to be deleted. But now I want to build this sequence. Well, that means my x is going to go 0, 1, 2, 3, 4, up to 35. That's easy. I just put x here where the 0 is. But how do I then produce this? 2, 3, 4. What do I do? Yeah, x plus 2 or 2 plus x, either way. So when x is 0, this expression will be 2. And so we'll be writing to the 0 place the 2. When x is 1, we'll be writing to 1, 3, 2, 4. That's beautiful. So now I'll get rid of this. And even though I could do it in the same loop, let me go ahead and go through a second time with a loop that will print these hotels off. So let me go ahead and print the x, comma, and then hotel sub x. And so now when I run this, it should load up that array, and then another loop that goes and just prints off the results of that array. And we've got all of those hotel names now built into that array of variables. Delightful. All right. So now we've got the names of the hotels sitting there. Ooh. If we're going to get as far as I want to get to go, we're going to have to speed up just a little bit here. So let's come over here. I've given us another sheet here called arrays. Now, the arrays themselves actually are just in memory. They're totally non-visual. You can't ever say, hey, show me those arrays. Closest you can come is saying, show me the locals window, and you can see all the values of the arrays in there, but you really can't see the array. And so what I've done here on the arrays sheet is just try to give you a visualization of what these arrays, one way to conceptualize these arrays. And so here's my hotel array. 0 is Sheraton Los Angeles Downtown Hotel. 1 is Salt Lake City. And that's the numbers that we see here. So here's where we've kind of printed off the data from the array, and here's us thinking of that array. Now, I've also given you another array here called the route. And this is an array that we're going to have to build, but this is how we're going to keep track of our stops. Which order are we going to go through these hotels in? So how do we say, and I've made this kind of small on purpose, how do we say start in Salt Lake City? I'm not going to put the name of the hotel here. I'm going to put something else here. How do I say start in Salt Lake City? Yeah, I'm just going to say the first stop in my route, so route sub 0, the first variable in this, is going to hold the index number of my hotel. So start at 1. That's this index right here. Says start in Salt Lake City. How do we say go to Las Vegas next? 7, because number 7 is the one in Las Vegas. You know, if the one we're going to after that is like number 12, I don't remember. Actually, I don't remember what the next one is, but if it was, that would be our next route. And so ultimately, we're going to have then each one of these of our little hotel indices to say that's the route that we're going in. So we'll be working with hotel numbers. When we want to print it out, no problem. We can say, look, you want to print out hotel number 1? Great. Go to the hotel array, pass the 1 into it, and it'll print out the name of the hotel. We have access to the name as well. Now, every array, so let's go ahead and declare that array up here. So we've got dim hotel as a string. Let's dim route as an integer. Okay, so at this point, we run our code, and our hotel now actually looks just like this. But our route is an integer. It can't be blank. These blanks don't really exist. So what is actually in our route right now? Say it louder. I heard it. I thought I heard it. Maybe. Yeah, it's just a bunch of zeros. Because these are variables after all, and each variable has a default value. So the way this actually starts off here is 0, 0, 0, 0, 0, 0, 0, 0, 0. 0 negative, that's no good. 0. They're all zeros. Okay, now, if I remember right, the algorithm that we're going to do is we're going to say, all right, let's find the closest city that we haven't been to yet. So we need to know if we've been to the city. How do we know if we've been to the city? In this structure we have here, how can we tell if we've been to the city? Yeah, the number of that hotel, or number of that city, is going to be in the route. So here's the problem. We're going to start off by saying, at first, we have been to no hotels. And so our first question is, what's the nearest city that we haven't been to? But there's a problem. If this has zeros in it, what is this actually saying? What hotel have I been to over and over and over again, if that's what my route is? All zeros here. Yeah, I've got that's an actual hotel. It's hotel number 0. So this is a problem that is going to surface later if we don't fix it now. And it turns out, I think it's a little bit better for us to fix it now, because when it shows up as a problem, it's really confusing. So let's fix this problem now, and then the rest of the problem will go a little bit more simple for us. So what should I put? I need to initialize this array to have some value in it besides, it can't be any value that's a valid hotel number. So what should I put in here? Letter would be great, but remember, it's an integer, and so it can only hold numbers. Oh, -1's a pretty good choice. Nice thing is an integer, I can go negative, because I'm not going to have a negative hotel. It doesn't matter how big the problem gets. You might say make it 37, because you only have, up to you only have 36, you'd be out of range there, but I got a 37 coded in here. I'm worried that I'll bump into it at some point, but I'm never going to bump into -1. So we can do this right in the same loop where we're initializing the hotel. Let's just come here and say our hotel, which is route sub x equals -1. So now, as I go through this the first time, route sub 0 is 1, then route sub 1 is -1, route sub 2 is -1, route sub 3, it's going to put -1 into every single one of those. Oh, that's great. We're going to have a bunch of -1s in here. So that way, whenever we write the code, which we won't do till next week, but whenever we write the code that says, have we been to a city, we're not going to accidentally think that we've already been to Los Angeles. So now we've got our route full of -1s. And let me reinforce here, the route isn't on this worksheet. The route is in memory. It's variables in memory. This is just so we can kind of look at it and think of what we're after. Now we've got to get to this next array. Oh boy. This now is where we have to think about post office boxes. Because now it's not just a single dimension array, not just a list of variables. Now it's like 2 dimensions. I've got a grid of variables. And I named this distance, but that's a bad name because I also named the worksheet distance. And if I have a worksheet with the same name as the array, it's going to cause a problem. So I'm going to change this from distance just to dist. So let's go ahead and create that array. So I'm going to come back to my code. Same thing when I declare this array. dim. Oh, yeah, route needs to be an array. Thank you. Oh, we need to redim it. Yeah, very good. Let's do that. We'll do that at the same time as we do this one. Okay, so let's dim dist now as a dynamic array. As integer should be fine. integer. And you're right, we need to redim our route. So route, redim, route, and we'll do this to hotel count -1. All right, but now let's look at this two-dimensional array as we redim it. Redim dist as, let me do it with constants first, and then we'll put the dynamic code in. 35, comma 35. Now, it doesn't have to be square. I could have 35 rows and 3 columns, and that would just give me an array of a different size. This one happens to be square, so they're both going to be 35. But I don't want, this is hard-coded just so you can kind of see it in its simple form. Instead of 35, how am I going to get to my 35? Hotel count -1, comma, hotel count -1. Okay, so now I've got this array declared, but what values are in it everywhere? Yeah, zeros are everywhere. The default value is zeros. Well, good news, the diagonal is supposed to be 0. That's what's actually supposed to be there. So I've already got, 35 of my, or 36 of my entries taken care of. Now let's go ahead and write a loop that will put in the rest of the numbers. We'll read them off the worksheet, off our distance worksheet, and we'll put them into the array. So I could kind of build this in with this loop, but I think it'll be simpler if we see this separate. This part here is the part that might bring you to tears. Okay, so I haven't had any tears yet today. My goal is to make at least one student cry. This is the chance where it might happen. So let's go ahead and get started. I'm going to say for x equals, now I don't have to start at 0 because I'm just going to work on one row right now because my 0 spot already has a 0 in it. It happens to already have the right value. Wonderful. So I'm going to say x equals 1 to 35. Next. Now, because my distance array is 2 dimensions, every time I refer to one of those variables, I've got to give an index for both dimensions. So dist, and let's say we're on row number 0, column number x. That is going to equal, and let me look at I'm just going to copy my distance expression here. I'm looking at my distance worksheet, row number 2, column number x plus 1. Is that right? My first distance is in column number 3. And so when x is 1, no, it's x plus 2. So when x is 1, I'm going to read from column number 3 and put it over there into x1. And that should do it. Let me go ahead and put a stop in right here so I can run to there and just see what I've got. So I should be able to look at dist sub 0. The only place I've ever written is to row number 0. And let me look at column number 0. By the way, the rows and columns are a figment of my imagination. As long as I'm consistent, the first one means row, the second one means column. If I want to think of it as turned on its side and the first one's column, second one's row, that's okay too. As long as I always think of those indices consistently. There's not really rows and columns, they're indexes. Because after all, they're pigeonholes, not really variables. Okay. So I should be able to look at that, and that should be 0, the default value. Let me go ahead and execute this line here. And there's that 0, but the important one is to see my 1, column 1. Didn't really mean to put the 0 in front of that 1, but it's okay to be there, I guess. Here's column 2, and I've got those numbers. Are those the right numbers? 691, 374, 691, 374, great. And take a peek at the very end, 35. 1139, is that what I'm after? Yeah, 1139, beautiful. And so I've got that first row done up. Wasn't so bad. But now I have to do something very similar to that 35 times. Now this loop is already going 35 times, and I've got to make that loop happen 35 times. Okay, so we'll do the same trick we normally do. I'm gonna take the code that I want to have over and over again. And I'm just going to copy it 3 times here. Now, how is this supposed to look? The first time, I'm going to start here in column number 3. The next row down is going to be 1 row higher. So instead of looking at row number 2, this is going to be row number 3. This is going to be row number 4. I'm going to be writing here to 1 and 2. But here I'm going to start at column 1 as I'm reading the data. So that says start here, but when I get to this one, I'm going to start in column number, the next one over, 3. And so, I'm sorry, my x, instead of my x starting at 1, I'm going to start at, I'm going to start this at 2. Let's try that again. So first time I'm reading from column 3, that's giving me 1 plus 2 is 3. Next time through, I'm going to start this at 2, which is going to give me 2 plus 2 is 4. Then I'm going to start at 3, which is going to be 3 plus 2 is 5. Okay, so that'll do it. So I've got to have like 35 statements like this. So let me take this first one and split it off and put it inside of a loop. Okay, so I got my old ones there. Get just to where I'm here. Okay. So I'm going to need another control variable. I'm going to need another for loop. So I'm going to come up here and make another loop here. Dim y as an integer. Now as I look at what y has to do, y, I need this to go from 1, 2, and 3. So I'm going to come here and say for y equals 1, 2. Do I have to go all the way to 35? Do I have to go all the way to row 35? And the answer is, let's go over. So here's that very last row. There's no data on the last row at all. So this really only has to go to 34. Next. And so now, instead of starting at 1 here, I'm going to start at y, because it's going to go that sequence 1, 2, 3. So that's going to give me my 1, 2, 3 as I go here. And now, instead of starting at row 0, or let's see, column 0, I'm now going to put y minus 1. That'll get me to the 0. And that'll be the same sequence, 0, 1, 2. And then here, I'm going to put y plus 1. Whew. So now this should be putting my distances in there. Now, I'm only copying that data in so far, but let's just run this and make sure I'm getting what I think I'm getting. Okay, good news, I'm actually executing, that's a plus. So dist, let's go ahead and look at that same first one on the row. So row number 0, column number 1 should be 691. Now let's look at row number 3, column number 4. Row number 3, column number 4, 0, 1, 2, 3, 0, 1, 2, 3, 4. That should be 2. Ah, we got the 2. So it looks like we've got the data now going in. This is a nested loop. And for the first time, we have started this loop off not with a constant, but with a value that changes each time, a variable to where this starts. Any tears yet? It's a little more difficult, isn't it? Yeah. So we got one more thing to do. And that is, imagine that we're trying to figure out all the distances from the Phoenician to all the other properties. Well, everything from the diagonal over has that information, but then I got to kind of turn here and go up to find out the rest of them. Now, my array is a square. I have allocated all of those variables, right? All of these variables that I have here, there's memory allocated for each one. And so I'm using the memory. I might as well simplify the problem just by putting in the rest of the numbers. So for this, I'm going to put my 691 right here. So now, when I'm looking for what's the distance from Salt Lake, I've got everything. It's all right here on this row. So what's my next one going to be? Here, I'm going to put my 653. And I'm going to, let's see, 653 and my 374. Ultimately, that's what I want. I want this thing fully filled out with the data so that I can just say, I'm trying to find out how far everyone is from Las Vegas. Look at the Las Vegas row, and that's all I have to think about, just that one row. So, how am I going to do that? Let me say it out loud and see if you can hear the pattern. When I write to row 0, column 1, I want to write to row 1, column 0. When I write to row 0, column 2, 374, I want to write to row 2. When I write to 0, row 2, column... Let's see if I can say it, then you can see if you can hear it. So if we're going to go to row 0, column 2, I have to write that same number in row 2, column 0. What is it? Yeah, I just have to flip. I just have to transpose the indices. So watch this. Here is where I'm writing that value into the first one, and now all I have to do is say write that same value into the opposite location. And so now, if I run that, I should be able to say ask for dist row 2, column 4, and that should give me the same number that's at row 4, column 2. And so now that array is fully filled with all of those numbers. That is a good place to stop for today. We have homework due Monday. Maybe some of you have picked. Maybe you've peeked at it. I mean, I know it's not due till Monday. But in that homework, it's probably the hardest homework of the semester. You're going to look through an array, and you are going to find the index of the smallest value in that array. In this case, it's going to be a one-dimensional array, so you're going to have to scan through it and then say, all right, where is this? You don't have to know what the smallest number is. You just have to tell me where the smallest number is, because that's the next step in this algorithm, and we're going to pick that up on Monday. So you may think, I'll just wait till after Monday because we're going to do something very similar to it in class. That'd be okay. But you might be bored Saturday afternoon and say, let's do that homework now. Get together with a buddy and figure it out. Question? What's the last chapter on the midterm? Oh, last chapter on the midterm is the stuff we've covered before today. Remember, there's a study guide that shows you chapter by chapter, but these arrays are not on the midterm. All right, thanks for coming. Class dismissed.